In this first section, we're going to be introduced to learning the differences between mean, median, and mode, and when each is most appropriate and what they're used for. They're all measures of a center of a pile of numbers. In other words, they give you one number that represents the center of a bunch of other numbers, but each center has a different use for different reasons. So let's say, for example, we look at this example where maybe you're a real estate agent, and real estate agents, great field of career opportunities. If you sell enough, if you're good at selling things, and you get think about 3.5% of each commission roughly is the standard sale. So if you sold a house for say $100,000 or a property for $100,000, 3.5% of $100,000 is $3,500. And if you are representing the selling and buying, you could potentially get both halves of the deal and get $7,000 or 7% commission. But if you work with a real estate group, you may have to share part of that. But let's say, for example, just to be in real estate, you have to be pretty good with some numbers and know which center is most appropriate to use when. Let's say if you have a client that is actually interested in buying some property near a lake, say for between $300,000 and $400,000, somewhere in that range, they want to buy some property for a lake, and you wanted to kind of look at all these properties that are for sale down this road. So I want the best way to describe all of these numbers that are down this one road. Probably the most common center that people consider first is the mean. So let's try to do the mean first. The mean simply is just where you take all the numbers and add them together and divide by the number of numbers that you actually put in for your data points. All right, so the number of data points. So we'll start with the first property is 87,000. You just got to watch all your zeros, plus 65,000, plus 115,000, plus 405,000, plus 580,000, plus 6,400,000. Just gotta make sure you don't use too many zeros or too few. 5,900,000 plus 2,600,000 plus 340,000 plus 315,000, and then divided by, I think there are 10 properties. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the average property down this road appears to be $1.68 million, if that's correct, if I have those numbers correct, if you put commas there. So if you told your client that was looking to spend between $300,000 and $400,000 that the average price of land down this road right here is $1.68 million or $1.7 million, I don't even think you're driving down that road. But yet that's very misleading, because there are several properties that are kind of within the price range of what the client's looking for. So even though the mean or the average is the most common, this is one of the examples where the mean fails. It's not the best measure of center in this example. So why is that? Well, let's think about it. Let's take, for example, look at the numbers that we have on a number line, a dot plot, what we could call. So let's say we have a number line that represents everything from 0 to 1 million, 2 million. Now realize we got to go all the way up to at least close to 7 million. So then we have 3 million, 4 million, 5 million, 6 million, and then 7 million. And now we're going to put some dots approximately where each of these properties exist. All right, so let's start with the first one, 87,000. All right, so if that's 1 million, 100,000 would be 1/10 of the way, so that would be like way back here at the beginning. All right, the next one, 65,000. That's even before that one. So I'm just going to put a dot right here above that to the just really close. Let me see if I can move that over just a little bit. So we'll say that's our 67, that's our 87. We'll just put those as close as we can. 115,000, maybe we'll put that just above it right here. 405,000, the next one. That's a little closer, it's almost halfway. 580, that's just past halfway. $6.4 million, that's all the way down at this end of the number line. 5.9 million, that's really close to 6 million, so that's going to be like right about there. 2.6 million, probably about there. 340,000, that's probably going to fill in that little gap that we have right there, little space. Oop. Let me see if I can fill that gap in. And then 315,000, I'll put a little dot, maybe if I had more room I'd put it like right about there. We'll just say approximately. Alright, so look at these dots. This dot plot shows that the majority of the data is all right here at the bottom end of that line, and we have 2 data points way far away from the group, and those 2 data points right there really screwed up the average. Those numbers right there are referred to as outliers. when you have numbers that are really far away from the center of the most of the data, you refer to those, let me see if I make this a little bit bigger, outliers. And outliers really mess up the mean as the best measure of center. So whenever you have outliers, it's actually more appropriate to use what's called the median. And so rather than actually calculate this the classic way, let me have your calculator do some of these for you. The calculator is very good at calculating the mean and median very quickly for you. So let's follow the directions here. It says what we can do is we can press stat 5 enter. I'm just following the directions here. And then it says press stat 1. And then it says clear out any old data, highlight the L1 and press clear enter. So it says press up, clear, enter. And I'm going to go ahead and while we're right here, I'm going to clear the L2 as well. So I hit clear enter on that one as well. And then I'm going to enter all the data points in like we did last time. So we started with 87,000. And then after 87,000 we had 65,000. And then 115,000. And 405,000. And then 580,000. And 6,400,000, one of the outliers. And then 5,900,000, the other outlier. Let me see, it was 5,900, and yep, that's correct. And then 2.6 kind of could be an outlier. We'll define outliers more in detail as we go on throughout the rest of this chapter. But outliers right now are just numbers that are really far away from the rest of the pack. Alright, so I've entered all the data in just as it said. So part 3, enter each value in L1 column, press enter after each entry. And then finally it says request the calculator's one variable statistics menu by pressing stat, move the arrow to the right to calc, and then 1, and then enter. There's the average, so it calculated the average for us that we did by hand here. And then if you scroll down, it actually gives you the median as well, which is basically a number that's smack dab in the middle. If you line the numbers up from smallest to greatest, it's the number that's exactly in the middle of all the data points. So we could do that not too bad by hand. Let's try that. So the smallest number that you see up there is probably 65,000. So I'm just going to write 65K to show you how the calculator came up with the number it did. All right, then after 65K, the next one is 87,000. So I'm going to say 87K, K for 1,000. So I've gotten rid of that one. All right, so let's see the next smallest data point, probably 115. And then after 115, the next smallest data point is probably 315. And then 340. And then 405. I'm just putting from least to greatest. And then I think next one will be what, 580. And then 2.6 million. That's right, just 2.6 million. We know what that means. And then 5.9 million. And finally, 6.4 million. I think that's all the data points. Let's count to make sure we got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough. All right, so to find the median, what you do is you kind of work your way into the middle. So you mark off one on each end, and then you mark off another on each end, and you mark off another on each end, and you keep trying to work yourself down to the middle number or the middle two numbers. In this case, if I mark out two more numbers, I won't have anything left, so I have middle two numbers. So the average of those two represent what's called the median. All right, so if I did this by hand, I would have done 340, let me put this in parentheses, 340,000, so 1, 2, 3, plus 405,000 divided by 2, and you see I get the same number, I get 372,500. Now the reason the median is such a better center for this, now think about your client again. What you're now saying is that the median price of a piece of land down that particular road is $372,500. It means half the prices are above this and half the prices are below this. That's a much better indicator. So anytime you have an outlier, a number way far at the end, like in this dot plot that we created, the median is the best measure of center. Alright, so in this example right here, I kind of wrote down on the next page for you, if you have the notes printed out before you, when it's best to use each one of the centers. Alright, so mean is the most common, most often used center. It measures the center of numbers, but it's only the best center when all the data points are relatively close to one another. Like there's no big gaps like we had in the other one. For example, you see I made a dot plot of this data set that was given. There's no huge gaps between any one of the 2 points, and therefore the mean is the best center for that particular data set. Just as we just determined when we did that first example in the front, when you have the median, you use whenever you have an outlier. For example, if I was given the data points 9, 31, 12, and 6,000, and 40, so I have all these data points that are really close to the bottom, and then I've got one outlier way out here at 6,000. The average of those 5 numbers is 1,218.4. None of those numbers except for 6,000, and actually none of the numbers are even close to the average, and it's because the outlier messed everything up. It's better to use the median, in which case you'd say that half the numbers are above 31 and half the numbers are below 31. So if you have one outlier or 2 outliers, it's better to use the median. Now the only other thing I can think of is the mode, and we haven't talked about it yet. Mode is simply when the data point occurs that's the number that occurs the most often. And you can actually have where you have 2 numbers occur the most often, and you can have what's called a bimodal data set, which means both numbers that occurred the most are a mode. So you can have 2 modes for the same data set. Or if you have no number occurring twice, you have no mode. So in this example I provided right here for you, I gave you a data set that had a substantial number of the same number in it. And usually the mode is considered one of the best centers if you have the data point show up in more than half the data set. So like in this example, if you 1, 2, 3, 4, 5, 6, 7, 8, 9, I have 9 data points, and of those 9 data points, 1, 2, 3, 4, 5, 6 of them are 5. So if more than half of the data set is the same point, the mode should be considered as a potentially best center in this case. All right, let me stop here and then we'll go on to the examples to try these out together for part 2 of the video of this section.